Hi everyone, I'm continuing to work on my game. In this episode, I'll show hunting in the demo build. I've already got wolves, rabbits, chasing, attacks, health, stamina and debug bars that show me what's going on with each NPC. There is a technical iteration where I'm checking how different systems work together. First, I'll explain how to read the bars above the creatures. Then I'll show a few scenes with wolves and rabbits. After that, I'll explain the systems behind them. Perception, the behavior tree, locomotion, movement modes, stamina, attacks, health and death. I'll also talk separately about the tools I'll need next: visual debugging, a behavior tree editor and debugger, pause controls, timescale controls, and proper debug controls. Before I show the footage from the build, I'll first explain what the bars above the creatures mean. This isn't the game interface, it's a debug overlay. I need it as a developer so I can see not only what an NPC is doing, but also what's happening inside it. Health shows how many health points the creature has left. This is important during the attack and after it. Stamina shows how much energy the creature has left. It matters during a chase because running and faster movement modes need to have a cost. Fear shows the reaction to a threat. For example, if danger appears nearby, the NPC's state can change. I need to see the change not only in its movement, but also in the data. Hunger and thirst are used for behavior related to finding food and water. Hunting is the main focus of this episode, but these states are also part of the general needs system. The idea is simple. If I can only see the picture, I have to guess why an NPC did something. If I can't see the births and statuses, I can't understand their reason. I won't start with the hunt itself. I'll start with a calmer example. Here you can see what the debug information about an NPC state looks like in the current build. In this video I am showing a scavenger, wolf and its fair bar. It's important for me to see states like this while the simulation is running. Fear isn't just a decorative bar, it's a state that can affect behavior later. An NPC sees something. The perception system provides a fact. That fact can become a threat or fear state. Then the behavior system decides what to do with it. Right now, I'm not trying to hide all of this behind a nice interface. It's the opposite. During development, I need to see these things clearly. If a state changes, I need to see exactly when it happened and what it caused. These bars are only the first layer of visibility into the system. The visual debugging system needs to be explained. I need to see more than health and stamina. I need to see the current target, the current action, the movement mode, the fair state, maybe the active behavior tree branch, and the reason why the behavior changed. For example, if a wolf stops chasing a rabbit, I need to understand why. Did it lose the target? Did it run out of stamina? Did the distance get too large? Did the behavior tree switch to another branch? Or is it a problem with locomotion? Without proper debug controls, this turns into gathing. But when you are tuning behavior, you can't rely on guessing. You need to see the data. So, one of the next tooling steps is to make better debug controls. I need to choose what to show, which NPC to inspect, which layers to turn on or off, and what information to display about the creature. Now, let's look at the example with the two wolves. Here I don't want to show two identical NPCs. One wolf acts like a hunter. It chases a rabbit and tries to kill it. The second wolf is more of a scavenger. It doesn't have to actively take part in the chase, but it can come over after the prey has already been killed. In the video, it almost looks like a small scene. One wolf hunts, the second one waits nearby, and then it comes over to the prey. But technically, something else is more important to me. Different NPCs can have different roles and different things they are interested in. One works with a living target, another can react to the result, like a corpse, meat, or another resource. So the death of the rabbit isn't just the end of an animation, and it isn't just removing an object. It's a change in the state of the world, and other systems can react to that change. This brings us to an important topic: roles inside the behavior system. The hunter works with a living target. It needs to find the prey, get close enough, chase it, and attack it. The scavenger can work differently. It might not be interested in the chase itself. It might be interested in the resource that appears after the target dies. This is a useful foundation for the future simulation. One event can become the input for another behavior. One NPC kills a rabbit, resource appears after that, then another NPC can react to that resource. Right now, this works in a simpler way. The corpse stays for a while, and then it disappears. But later, I want to expand this chain. Bones should remain after the corpse, and then those bones should slowly disappear from the world. The death of the creature shouldn't mean that the object disappears right away. First, there is body, then there are remains. After that, the world slowly cleans itself up. Different NPCs and systems can react differently at each stage. This isn't a complete ecosystem cycle yet, but that's the direction. The behavior of one creature changes the data in the world. It doesn't just end by itself. Now, let's look at a few hunting scenes. It's important to look at more than the final result, whether the wolf caught the rabbit or not. It's also important to understand why it happened. The result of a chase depends on the distance, speed, turning ability, stamina, movement mode, and the current parameters of each animal. The balance is still rough. In the future, I want a wolf's chance of a successful attack to be around 20 or to 30%. That's only a rough estimate, not a final number. I'll need to test it with statistics, a lot of simulations runs, and proper scene conditions. Right now, rabbits have almost no real chance to escape in open terrain. They don't have burrows yet. They don't have homes, shelters, or any real terrain advantage. So, if a wolf has already reached a good chasing distance, the rabbit is in serious trouble. The rabbit is more agile and can turn better. But that isn't enough in an open area. The wolf has more endurance, and during a long chase, that has a big effect on the result. So the current death rate of rabbits is higher than it should be in a more complete version. This isn't the final balance, it's a demo of the current mechanics. Different results shouldn't come from separate code for every situation. They should come from parameters and profiles. An animal has speed, turning ability, stamina use, health, a behavior type, and a set of available actions. For example, a rabbit can have less health but turn better. A wolf can be worse at sharp turns but have more endurance and be more dangerous at close range. If, if I add burrows, shelters, and more complex terrain, rabbits will have proper ways to escape. Then the result won't depend only on running across an open field. It'll also depend on whether the rabbit reached a safe area, whether it chose the right direction, and how far away the wolf was when it noticed the rabbit. That's why I can't judge the balance only by the current scenes in open terrain. Right now, I'm testing the mechanics. I'm not tuning the final ecosystem. Now, let's talk a little about the behavior tree. Behavior tree is a way to describe behavior as a tree made of nodes. It's not the only way to build AI, but it works well for tasks like this. You can build behavior from conditions, actions, and control nodes. The tree has several main types of nodes. A condition node performs a check. For example, does the NPC have a target? Is the target alive? Is the target close enough to attack? Does the NPC have enough stamina? Is there a threat? A node like this usually doesn't change anything in the world. It just says whether the condition passed or failed. An action node performs an action. For example, attack, write a value to the blackbird, request movement, set the running mode, or clear the target. A sequence is a node that says, do these steps in order. It goes through its child nodes from left to right. If one of them fails, the whole sequence fails. This is useful for logic like this. First check the target, then check the distance, and then attack. A selector is a choice node. It tries different options in order and picks the first one that can run. For example, if the NPC can attack, it attacks. If it can't attack, it tries to chase. If it can't chase, it moves to another branch. There are also decorator nodes. They wrap another node and change the conditions under which it runs. For example, a decorator can add cooldown, reverse the result, or allow a branch to run only when another condition is true. Every node returns a result: success, failure, or running. Success means the node completed successfully. Failure means the node failed, or its condition didn't pass. Running means the action is still in progress. For example, the NPC is still moving toward the target. Right now, behavior is defined through data, and I can show it as a JSON. It isn't the most convenient format for a person, but it clearly shows the main idea. The behavior is built from conditions, actions, and branches. For example, the tree can check whether there is a target, how far away the target is, whether the NPC can attack, whether it should keep chasing, and which movement mode it should request. The behavior tree shouldn't try to do everything by itself. It shouldn't scan the world, calculate movement physics, or calculate stamina use. It should work with the prepared facts and call clear, specific actions. The blackbird works as a working memory of the behavior. It can store the current target, the target position, the distance, the movement mode, and temporary values used during a chase. The tree nodes read this data and write new data. But editing complex trees by hand in JSON is only a temporary solution. The larger the behavior gets, the harder it is to read and maintain. So later I'll need a behavior tree editor, and I'll need more than an editor. I also need a debugger. I need to see which branch is active right now, which mode passed its condition, which node failed, where the behavior switched, and why it picked that path. Without a tool like this, complex trees quickly become hard to work with. JSON is good enough for now, but if the system keeps growing, I'll need a proper visual tool. Now, I'll break down the pipeline behind these scenes. Hunting is a good example, but this is not only hunting pipeline. It's a general NPC behavior pipeline. The first layer is perception. It decides who can see whom. During a hunt, the wolf needs information about possible prey, and the rabbit needs information about a threat. But the same layer can also be used for other tasks, like finding a resource, noticing danger, or detecting an object of interest. Perception doesn't make the final decision, it prepares facts. There is an object nearby. The distance is this. The direction is this. The target has the right tags. The threat is still active. The second layer is target and threat facts. This means that behavior doesn't receive only raw objects from perception. It receives more useful data, like the current target, the current threat, the position, the distance, and the direction. This is important because the behavior system shouldn't search the whole world by itself every time. It needs prepared facts that it can work with. The third layer is needs and behavior selection. An NPC can have hunger, fear, thirst, and current target and a current action. At this level, the system decides what's more important right now: hunting, running away, eating, drinking, finding a resource, resting, or doing something else. These are where priorities appear. If an NPC is hungry, but there is danger nearby, its behavior can change. If there is no threat, it can keep looking for food. If the target is lost, it needs to evaluate the situation again. The fourth layer is a behavior tree. When a behavior branch is selected, the tree starts running it. It checks conditions, works with the blackboard, and calls actions. The blackboard is the working memory of the behavior. It can store the current target, the target position, the distance, the selected movement mode, and temporary values used during a chase or escape. Next comes to locomotion system. It receives the movement intent. For example, move toward target, move in a direction, maintain a speed, or a switch to another movement mode. It's important that locomotion doesn't know why the NPC is moving. Hunting, escaping, finding food, or moving toward water provide different input data, but they shouldn't require a separate locomotion system for every situation. After that, the system selects a movement mode. It can be walking, sneaking, running, sprinting, and so on. Each mode has a speed and a stamina cost. Then stamina comes into play. If a movement mode is expensive, it uses stamina faster. If there isn't enough stamina, movement should slow down. The NPC shouldn't be able to stay at maximum speed forever. After that, the action produces a result. During a hunt, the NPC can reach attack range and perform an attack. In another behavior, the result can be reached water, eating, resting, interacting with an object, or doing something else. If the action is an attack, it changes the target's health. If the target runs out of health, it dies. After death, a corpse or another resource can appear, and that resource can be interesting to another NPCs. That's why hunting works well as a demonstration. It shows almost the whole behavior pipeline at once. from perception and target selection to movement, stamina use, actions, and changes in the world. But the pipeline is bigger than hunting. The same structure can later be used for escaping, finding food, going into water, reacting to threats, using homes, reproduction, and other behaviors. Movement also needs a separate explanation. The locomotion system shouldn't know whether the NPC is hunting, escaping, or just moving to a point. It only needs a task: where to move, which mode to use, which speed to maintain, or which direction to follow. For example, normal movement can use walk. A chase can request run or burst, but run and burst aren't free, they use stamina. This is important for balance. If the fastest mode is free, it becomes the default mode, and the whole system loses its purpose. But if every mode has a cost, meaningful choices appear. A wolf can quickly close the distance, but I'll spend energy. A rabbit can make sharp turns, but it can't do that forever either. Right now, in the current demo and in open terrain, the wolf has a strong advantage. It has more endurance, and the rabbit has no shelters. But when burrows, shelters, and more complex environment are added, stamina and movement modes will become more interesting. The next important tool is time control. It isn't a complete tool yet, but I need it. For scenes like these, I need pause, slow motion, and fast forward controls. At normal speed, some parts of the behavior are hard to understand. The wolf gets closer, the rabbit turns, stamina drops, the behavior tree switches branches, and you only see the final result. But I need to see the exact movement when the switch happens. I need to pause the scene and inspect the distance, the current targets, the stamina, and the active behavior. Then I need to slow it down and understand exactly where the system worked well or where it worked badly. I need this not only for a better presentation, I also need it for debugging and balancing. Without time controls, complex scenes are harder to analyze. I also want to talk separately about balance. So there is no wrong impression. Right now, the chance of a rabbit dying is too high, and that's expected. Under the current conditions, the rabbit has very few ways to escape. In open terrain, if a wolf has already started a proper chase, the rabbit has almost no chance. The rabbit can be more agile, but the wolf has more endurance. Without a burrow, shelter, a complex terrain, the rabbit often just loses the distance battle. So the current scenes shouldn't be treated as a final balance. They are demonstration of the mechanics under simplified conditions. When burrow shelters and more complex environment are added, the situation should change. If there is a safe place nearby, the rabbit can reach it in time. If it's an open field, the result will be very different. If the wolf is far away, the chance of escape is higher. If the wolf is already close, that chance drops quickly. So, hunting balance isn't controlled by one speed setting. It depends on the environment, distances, shelters, stamina, behavior, reactions to threats, and statistics from many simulation runs. I'm still thinking about what to do next, because there are several possible directions. The first direction is tools. I need to expand visual debugging, make proper debug controls, build a behavior tree editor and debugger, and add pause and time scale controls. The second direction is the NPCs and the environment. Rabbits needs burrows or other homes. They need conditions where they don't just run across open terrain, but have a real chance to escape. The third direction is reproduction. and a longer NPC's life cycle. If creatures can die, the population also needs a way to recover. Otherwise, hunting will quickly reduce everything to zero. But reproduction can't just be added with one button. It immediately creates questions about balance, resources, limits, and stability. At the same time, I would to bring these mechanics to a more production-ready technical state. I don't mean that the final game will be ready. I mean that the system needs to be stable, visible, and controllable enough to build the first gameplay on top of it and to continue developing safety. The system has grown a lot. It has good test coverage, but as the scale increased, I started to need more visibility into its internal state. Normal logs aren't enough anymore.